The following video lectures are about Chapter 12, which is about statistics. And fundamentally, statistics is about data. And so there'll be 5 objectives that we'll be looking at here. One would be how we organize data, in other words, the visual display of data. Then we'll be discussing the measures of central tendency, in other words, where do the data kind of bunch up, where's the center of the distribution, if possible. And then this measure of dispersion, how far the data are apart. And then there's a measure of position, where's a particular data value and how do we measure that. And the last one would be the normal distribution, which is absolutely critical in statistics. So this section is 12.1, and it is about visual display of data. And as usual, there's some definitions, and one of them is the amount of a population. And so the population includes all items of interest. And the sample includes some, not necessarily all of the items of the population. And so you've seen a Venn diagram, and we're going to make one of those in just a moment. So this population and sample would be the key verbs in this chapter for the section here. But we use these words throughout this whole chapter 12, populations and samples. Now, next are the two main areas of study of statistics. And so one would be called descriptive statistics, and that consists of collecting, organizing, and summarizing and presenting data. And again, data is just information. So describing the data that we have. And this can apply to the populations and also the samples. And that's what we'll be doing here next. Then the other part of statistics, the second area, is that of inferential statistics. So here we draw conclusions or make inferences about populations. And these are done on the basis of information from samples taken from those populations. And as an example, if people want to know, let's say, for politics, what the preferences are, they don't ask the whole United States population, about 300 million people. There would be way too many and would take too long and so on. So instead, small samples are taken, and from asking them about certain issues, they then infer from these samples to the whole population of the United States. That's called inferential statistics. Next, we have a few more definitions of terms. And one is that information that has been collected but not organized or processed, that's called raw data. And data comes in form of quantitative or numerical information, or also qualitative, non-numerical, in other words, descriptive. And we look at that in just a moment. So raw data, then quantitative or qualitative data. Keywords here. One way to organize data is through a frequency distribution. And so when there are many repeated items, it can be organized into a frequency distribution, which lists only the distinct data values x along with their frequencies. That's called a frequency distribution. And we'll be studying one of those in just a moment. So the frequency designates the number of times the corresponding item occurs in the data set. It's also helpful to have a relative frequency for each of the distinct items. And this is a fraction or percentage of the data set, and it's represented by the item. So if n is the total number of items of a given and a given item X occurred X times, then the relative frequency of X is given by F divided by N. That may all sound very abstract, but when we look at it from a data setting here, it becomes apparent what that all means. Let's look at a very simple example. Favorite numbers. The following data are the favorite numbers, single digits 1 through 9, of the 24 pupils of a second grade class. So here are all the numbers listed: 4, 7, 2, 7, 6, 1, etc. And because there are 9 numbers and there are 24 students or pupils, some numbers will definitely repeat. So the assignment is the part A, construct a frequency and relative frequency distribution, and then construct a histogram and a frequency polygon. So what's assumed here is that you have read the chapter and that these words have meaning to you, like histogram and frequency polygon, but I will construct one for you and that will also explain it. So here's our data, and here I made up a frequency table. And so here are the values for X, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're going to enter the frequency. In other words, how many times do we have a 1? Well, when we look at the data, the 1 shows up twice, so its frequency is 2. And when we look at how many times the number 2 shows up, is 1, 2, 3, 4 times. So in other words, the frequency for number 2 is 4. And so as we go through the numbers, we find out that the number 3 shows up once, and the number 4 occurs twice, and the number 5 is 4 times, and the number 6 shows up twice, and 7 4 times, and 8 would be 2 times, and 9 is 3 times. So when we add up all the frequencies, that is equal to 24. Now we're going to do the relative frequency, which is the third column. The frequency divided by n. So n equals 24. Okay, so now we divide every number by 24. So 2 divided by 24 there would be 8%. So the relative frequencies are often given in terms of percentages, either with a percentage symbol or in decimal format. You see it in both presentations. Then 4 divided by 24, that would be equal to 17%. It is not exactly 2 times, because of rounding. And then there would be 1 divided by 24, and there would be, again, rounded as 4%. And then 2 divided by 24, we had that one. That's equal to 8%. And 4 divided by 24, again, we've had this before. There was 17%. And then 2 divided by 24, that's 8%. And 4 divided by 24, that's 17%. And so on. 2 divided by 24, 8%. And then 3 divided by 24 would be 13%. And all this adds up to 100%. Now, when you do this, in general, it may not add up to exactly 100%, and that's due to rounding. But in this case, it worked out. So that's how we establish a frequency table and the relative frequency column as well. Next, we're going to construct a histogram from the frequency table. And so on the horizontal axis, we have the favorite numbers. And so 1, 2, 3 to 9. And then on the vertical axis, we plot the frequency. For example, the number 1 occurs twice. So in other words, here's the frequency for number 1. And the number 2 occurs 4 times, so its frequency would be 4. And then we draw some vertical lines. So now we indicated the frequencies for number 1 and number 2, and we're going to fill up the rest in just a moment here. So it's very common if the frequency on the vertical axis, and you could also have the relative frequency on the vertical axis. In fact, what you see in some histograms is that you have the data values on the horizontal axis, and on one side you have the frequency, and on the right side, on the vertical axis, you have the relative frequency, or vice versa. Relative frequency here, frequency there. So a histogram can convey a lot of information in very small space, but basically it's just a graphical representation of a frequency table. That's really what a histogram is. So here's the completed frequency table, and here's the completed histogram. And the last thing would be to construct a frequency polygon. So let's do that. And basically, frequency polygon is an abstraction of the histogram where we connect the corners of the histogram and just have a line graph. Now, sometimes in some books you see that the frequency polygon is on the corners of the histogram bars. Others center it, so there are different ways of doing it. So we're going to use the corners, and so this would be our first point, that would be our second point. In fact, I may just, let me just do a separate one. So just as the basis for our histogram was the frequency table, the basis for our frequency polygon is our histogram. So we just go by the histogram, and you notice that the horizontal and vertical axes are labeled the same way. Favorite number on the horizontal axis and the frequency on the vertical axis. So the number 1 occurs twice, so we go to point 2 here, and then number 2 occurred 4 times, so we go to 4 here, and the number 3 was 1 time, so we go to 1, and the number 4 was twice, so we go to 2 there. And then the number 5 was 4 times, so we go up to 4, and so on. And then we connect these dots with a line. So here we have connected the first few dots with line segments, and now I'm going to finish it up. So here's the completed frequency polygon. And as you can see from looking at the table of values, or even the raw data, it doesn't give you much of an impression of what it looks like. But the graphical representation in form of a histogram and or a frequency polygon gives a very good idea of what the data actually looks like. So you can see trends better, and most people are visual anyway, so the visual display of data has numerous advantages over looking at tables. Now, quite often you have data sets containing large numbers of items, and they are often arranged into groups or so-called classes. And as you can see in the next example, there's quite a few numbers there. And so all data items are assigned to the appropriate classes, and then a grouped frequency distribution can be set up and a graph displayed. And there are really no fixed rules about how to do this, but there's some general principles. And number one would make sure that each data item would fit into only one class. Number two, try to make all classes the same width and make sure the classes don't overlap. And generally use from 5 to 12 classes. If you have too few or too many classes, they'll obscure the tendencies in the data. And again, that's what we want to do in a graphical representation. So let's look at number 9 here, exam scores. The scores of the 48 members of a sociology lecture class on a 50-point exam scale were as follows. So here are all the scores, 48 of them. And there are three things we need to do: construct a grouped frequency and relative frequency distribution, and then construct a histogram and a frequency polygon. So just as we have done it before. The only difference is now that we have classes of numbers that we do it with. So here's our table, and based on the example of table 3, we have our class limits here, and I decided on a class size of 5, so we go from 21 to 25, and we go from 26 to 31, to 30 rather, and from 31 to 35, and from 36 to 40, and from 41 to 45, and from 46 to 50. So the next thing we do is we go through the raw data and count how many are in the interval from 21 to 25. And by looking at the data, you really have to go through the data here, and I did that for you. So there's one of them, one in the class size of 21 to 25. Then the next one, 26 to 30, there happen to be 2. And then from 31 to 35, there are 5. 1, 2, 3, 4, 5. From 36 to 40, we find there are 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 2 more for 12. And then between 41 and 45, we find a 16. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5, and 1. So I did the counting ahead of time to save time from entering the tally marks. And then from 46 to 50, there were 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 2 more. So we have the frequency now in simple numbers. We have 1, we have 2 for second, 1 for second class, and then 5, and then we have 12, then we have 16, and then we have 12. And there's a total of 48, so n equals 48. So then for the relative frequency, we need to divide each number, each frequency, by 48. So 1 divided by 48 That's approximately 2.1%. And you may want to use a calculator for that. And then 2 divided by 48, that's approximately 4.2%. And then 5 divided by 48, that's equal to 10.4%. And 12 divided by 48, now that's equal to 0.25%, or 25% rather. And 16 divided by 48, that's 33.3%. And then 12 divided by 48 is 25%. So that's how we establish the relative frequencies, just like in the previous example. We begin our histogram by patterning ourselves after the frequency distribution. So what we have on the horizontal axis, we have the exam scores by class, like 21 to 25 and 26 to 30, etc., to the right. And then on the vertical axis, we have the frequency, 5, 10, 15, and so on. And now we're going to construct the histogram. So here's our completed histogram with the horizontal axis indicating the exam scores and their classes. And then on the vertical axis, we have the frequency. And so the bars, the histogram, gives you a visual presentation of what was in the frequency table and the relative frequencies as well. So that's our histogram. And I just decided to make the frequency polygon to draw it on the same histogram. It look, you see what it looks like in just a moment here. So in this case, when we have groups or classes, we go from the midpoint to the midpoint to the midpoint. So here's what we'll see as a frequency polygon when we connect these dots. So here's the completed frequency polygon, and as indicated in the heading, it's a histogram and a frequency polygon on the same graph. I hope this provided some guidelines for you to do your own work when it comes to organizing data in form of a frequency table, a histogram, and a frequency polygon. When you look at the frequency table, the tally marks give you a pretty good idea how the data are distributed. In fact, you can even say that the tally marks are like a histogram turned on its side. But once we go to the relative frequency, all the specific data are lost. Even in the histogram, we only know that there's so many in the class from, let's say, 46 to 50, but we don't really know what the data is. So there is one representation of data that avoids this. We can still see the original data, and it's called stem and leaf display. So that's what we'll be doing next. In example 15, we are supposed to construct a stem and leaf display. And what we see here are the data. And the data are the daily round-trip distances to school in miles per 30 randomly chosen students attending a community college in California. So here are the distances in miles randomly arranged. So what we'll do is we'll use the original data, but we split it up in a certain way. And so what we'll do in the stem and leaf display, here on the left side of the vertical line are the stems, and to the right are the leaves. And the stems, in this case, are the tens. So for example, there are numbers like 5 and 4 and 9 and so on. So there are no tens. So for the tens, there's 0. But then we can write, there's an 8 and a 5, 8 and a 5, 8 and a 5, and a 4 and a 9, and a 6, and another 9, and a 4, and an 8. So those are the single digits. And then for the tens, we notice there's a 16. So we write as a 1 and a 6. And a 10 would be a 1 and a 0. So in other words, here we write the digits that follow the 1. So then there's 11, 1, and a 1. And then there's 18. So there's a 1 here for the 10, and there's the 8, etc. And so we write all the double digits now with the tens on the left side, and then the single digits on the right side. 2, 4, 0, and another 2, another 18. Here's the other 18. So we make it an 8, and the 16 it would be a 6, and a 3 for the 13. So we don't even need to place these the data in any particular order. We can do it right from the raw data. And then we look at all the 20s. So in other words, the stem would be a 2, and now we're looking for all the numbers in the 20s. And it begins with a 26. So we put a 2 and a 6. And then next is 21. So it'd be a 2 and a 1, etc. So I think you're getting the idea. And there's another 2. 25, so we put a 5 in here. Another 21, so 1 goes here, and the 23 over here, so the 3 goes there. And then we go to the 30s. So again, the stem would be a 3, and the leaves with all the numbers with the 30s. So 30 itself being one of them, so 30. And then there's 34, so we put a 4 here, and 36, so with a 6 going there. And then the last would be the 40s, and there's only one of them, 44, so there's 4. So that's our stem and leaf display. And again, the nice thing about it is it retains the original data, and it looks like a histogram just turned on its side. So if I turn it around, then the numbers would be the vertical bars, so to speak, and the length indicates how many there are per group. So stem and leaf displays can be very useful, and again, you can see at a glance the distribution of the data. Section 12.1 ends with a discussion of bar graphs, circle graphs, and line graphs. Let me make the following comments. Number 1, I recommend you really study example number 4, and that is how to interpret a bar graph, and also the subsequent example 6, interpreting comparison of line graphs. And but for constructing bar graphs, circle graphs, and line graphs, I highly recommend you watch the video that is displayed here. It's a YouTube video, and I will also place that link directly in Canvas so you can click on it and watch it. You don't have to retype it. So become familiar with Excel, because that's what everyone is using nowadays, or Google Sheets, very similar to that. But you can actually get a free Microsoft 365 suite free of charge as a as a student at Folsom Lake College, and you can call Canvas support. They can help you with that. So I really recommend you learn some of the basics of Excel. It is not very complicated, and the video has some excellent instructions. Of course, feel free to search youtube.com for additional information on how to use Excel for creating visual display of data, bar graphs, circle graphs, line graphs, and there are many other things you can do. But anyway, the basic ones are in Excel and very, very easy to use. Maybe 20 minutes, half an hour or so would make you, quite proficient in that with that tool. This concludes section 12.1.